Hello guys, welcome to our channel Niperian Solutions. So today we are going to discuss about the nuclear magnetic resonance, that is very important topic from the exam point of view. So we will discuss the important MCQ one by one, right? So let's start with first one. So the first MCQ is how many NMR signals are formed for 2-chloropropene, right? So first of all we have to know the structure of the 2-chloropropene, right? So what is the structure of 2-chloropropene? That is the first one, right? This is the structure of 2-chloropropene. So here are accordingly how many NMR signals are there. So here is one CH3 group, right? This one, and here is a CH2 group, right? CH3 and CH2. Okay, I am writing just here CH3 and CH2, right? Okay, so generally if we are looking in the structure, so here are only two signals, right? This CH3 is 1 and these two protons are 2, but here is the effect of, that is the minus I effect or the electronegativity effect here. So this proton, which is due to stereochemistry, which is close to the chlorine, is having the another signal, and this proton is showing the another signal, right? So means here total 3 signals are there, that CH3 is 1, this proton is second, and this hydrogen is the third one, right? So similarly if chlorine is not there, right, if we are looking the structure of this one, if chlorine group is not there, then definitely the signals are the different, because this 2CH3 is giving one signal, this one, and this one is giving the only one signal, right? So means only two signals are in the this structure. So here is total the effect of the electronegativity, so please don't get confused in this one. So here are how many signals are in 2-chloropropene. So our answer is the 3, right? I hope this one is clear to you guys. The next question, NMR signals in case of 1,2-dichloropropane, right? So what is the structure of 1,2-dichloropropane? That is the structure of 1,2-dichloropropane. Here also the similar situation, here is the chlorine is there, so that is electronegative group, right? So here are also these 3 protons like CH3, this one, and this one, this give a single peak, means one signal. This hydrogen is giving also one peak, and this one is also giving another peak. So means there are 3 peaks, and this hydrogen, specifically this one, right, this is giving the different signal because it is closer to the chlorine group, right? So means in this structure also you are getting total 4 signals, right? There is the one, this one is the another second, this is the third, and this one is the fourth one. So these kind of signals you are showing in the this structure, right? So means total 4 signals are there in the structure. Okay, so what is the answer here? Answer is the 4 signals. Okay, next, write the multiplicity of the signals in CH3 CH2O CH2 CH3 in the NMR spectrum. So that is the very simple question, that is the diethyl ether. So here are the options are 2 triplet, a triplet and quartet, 2 singlet and 2 triplets, right? So let's see the structure of diethyl ether. So first of all we have to see how many signals it is giving, right? Okay, so this proton CH3, right, it is giving a one signal because these two sets of proton are very magnetically and chemically equivalent, right? So that's why it is giving a one signal, and this one is giving another signal, means only 2 signals it is giving, right? So in the diethyl ether only 2 signals are there, right? But our question is not the signals, our question is the what is the multiplicity, right? Okay, so I think you are clear with the signals, how many signals it is giving. So to now we are seeing the multiplicity, what is the multiplicity of that specific protons, right? So here this one, right, and this one, it is the CH3 and this is the CH2 protons, right? So this CH2 proton giving a quartet, right? That CH2 proton giving a quartet, because what is the rule of the multiplicity? That is the n plus 1. And what is the n? N is nothing but the that is the number of hydrogen to the adjacent carbon. तो इसके adjacent carbon में क्या है? CH3 है, right? तो CH3 plus 1 that is the 4, like 3 hydrogens है कार्बन पे. तो अगर हम उसको n plus 1 करेंगे तो it is giving a quartet signal. Similarly for this one, what it is showing, right? So that is showing a quartet, and for the CH3 this one, it is showing a triplet, right? So means in this structure we will get one triplet and one quartet. So that is our answer, right? So here our answer is B, right? A triplet and quartet. Again they are asking, write the multiplicity of the signal in the CH3CH2OH, means that is the ethanol. So simply if you are looking a structure in the ethanol, so there is CH3CH2OH, means OH is giving a single peak, then CH2 is giving a 1 and CH3 is also giving 1, means there are 3 signals in the ethanol, right? So that is clear about the signals about the ethanol. Then what is the multiplicity, right? So here that OH, that OH gives a singlet, right? Right. So this one OH that gives a singlet, right? Here it is giving a quartet. CH2 is giving quartet because in adjacent there is a 3 hydrogens. So adjacent carbon and carbon having a 3 hydrogens, so n plus rule, so it is a quartet. Similarly in CH3 it is giving a triplet, right? Means triplet, quartet and singlet. So what is the answer here? Triplet, quartet and singlet. So option A only, right? Here is the option A only, a singlet, triplet and quartet. So that is your answer, right? Okay. So in the next question, yeah, here is the different multiplicity of the singlet, doublet, triplet, quartet. So accordingly, what is the peak area ratio? That is also very important. In many times exams they have asked what is the peak area ratio for a doublet, what is the peak area ratio for a quartet. So you have to remember, guys, right? So you have to remember this one. Okay, next. In an organic compound, the proton linked to the sp2 hybridized carbonation is more deshielded than linked to. Okay, very interesting. So अब इसमें क्या पूछा गया है? In an organic compound, the proton linked to sp2 hybridized. So first of all, we have to know what is the effect of the hybridization on the NMR, or what is the effect of the hybridization to the chemical shift or the delta values, right? Okay. तो हम पहले देखते हैं what is the effect, then we will move to the answer, right? So effect of hybridization on chemical shift. So here the delta scale, so that is the 0 to 12 ppm. So always the effect of hybridization like sp2 is greater delta value then sp and then sp3 in delta scale, but that is totally opposite to in the tau scale, because in tau scale sp3 hybridize are more values than sp and then sp2, means delta scale and tau scale are totally opposite or totally reverse to each other. So okay, so that is clear, right? sp2 is greater than sp and sp is greater than sp3, right? Okay, so what is the question, right? So sp2 hybridized carbonation is more deshielded. Just now we have seen in the delta scale sp2 has having higher delta values comparatively sp3 and sp2, means the answer is both of this, right? Right, means sp2 is first, then sp and then sp3. That is the order of hybridization in the chemical shift. These are some examples of solvents that is used in the NMR, that is carbon tetrachloride, carbon disulfide, deuterochloroform or hexachloroacetone. We are not using the solvents which contain the hydrogen, like in that hydrogen is present, so we are not using that type of solvent because itself it giving that NMR peak. So to avoid that, we are not using that type of solvents, right? In next, in ethyl benzene, the tau value for CH2 proton will be dash dash than those of CH3 protons, right? In ethyl benzene, right? Right, so that is the structure of ethyl benzene. So in ethyl benzene, they are asking for this CH2, right? Okay, I will just change the color. Okay, so they are asking for CH2, right? So if you are looking at the structure, so this aromatic proton having the sp2 hybridization, so it is means it is having the greater value of delta, then CH2 and then CH3, right? Both the carbons or that hydrogen attached to that carbons are sp3 hybridized and here is sp2 hybridized, right? But that CH2 is attached to this system like aromatic ring, so CH2 is giving a higher delta value. यहाँ तक सब clear है, right? CH2 giving higher delta value than the CH3, but like this sp2, this one, this is the highest value, right? This is the highest, then this is second number and that is the third number, but that is related to the delta value. What they are asking to us, they are asking to us a tau value, right? Tau value, so that is totally opposite, right? So means what is the answer here? That will be the lower than those of the CH3 protons, because they are asking the tau value. If they are asking the delta value, definitely it is higher, right? But they are asking the tau, that is very important, so that's why our answer is the lower, right? Okay, here is the structure of that ethyl benzene. So what about the delta scale? In delta scale in ppm, that aromatic protons having the higher value, then CH2 and then CH3. So aromatic giving the multiplet, CH2 is giving the quartet and that CH3 is giving the triplet, so that is multiplicity also given here. So in tau scale that is totally different, because sp3 hybridized carbon is the first, then the CH2 and then the aromatic proton. So these two scales are totally different or the opposite to each other, right? Okay, next, out of the olefinic, aldehydic and aromatic protons, so they are just asking the what is the decreasing order. So here are olefinic, aldehydic, aromatic, then aldehyde, olefin, aromatic, then aromatic, olefinic, aldehydic and olefinic, aromatic, aldehydic. Okay, so just very simple question. So just we have to know, so what is the delta values for the different functional groups. So what is the answer here? Here answer is our aldehydic, olefinic, aromatic, because aldehydic and acidic proton, they are giving the your delta value in 10 to 12 ppm. So these are the highest deshielded functional groups, aldehyde and acids, right? So that is why our answer is aldehydic, olefinic and aromatic. Option B is correct over here, right? So in the next question, aromatic proton having the chemical shift value. So just now we have discussed. So what is the functional group here? That is the aromatic protons. So what is the answer over here? That is the 6.5 ppm, right? So aromatic proton giving in the 6.5 to 7.5 ppm in between. The range is given for the aromatic proton, they do not have the fixed values, because there are many substitutions to the aromatic, sometimes electronegative, sometimes electropositives, so depending on the functional group, but the range is 6.5 to 7.5 ppm. And what is the like multiplicity they are giving? They are giving the multiplate. They cannot give like singlet, doublet, triplet, right? Always aromatic protons are the multiplate, right? Okay, so the next question, here are the some, oh, that is very important. Here are some functional groups and giving the chemical shift values, so you have to go through these guys, because this is very very important from your point of view exam. Okay. Okay, next one, which of the following compound having the highest de-shielding effect? That is also very interesting one, because there are the factors affecting the chemical shift, right? So how your delta value changes, so there are the different factors. So here also you can see the ethyl bromide, ethyl chloride, ethyl fluoride and ethyl iodide. So just you have to know guys, so what is the effect of that electronegativity, or what is the effect of the inductive effect on the chemical shift, right? So the effect of electronegativity, so electronegativity is directly proportional to the de-shielding. And what is the de-shielding? De-shielding is nothing but the downfield, and downfield is nothing but the greater the delta values. I hope you guys are clear. Electronegativity is directly proportional to the de-shielding, right? Means the compound which is having the highest electronegativity, which is having the highest delta value, right? So from the option, which one is the having the highest electronegativity? और हम इसको ये भी बोल सकते हैं कि माइनस आई इफेक्ट, द कंपाउंड विच इज शोइंग द माइनस आई इफेक्ट, विच इज also showing the de-shielding effect or the downfield effect. So here is the our option, or our answer is like ethyl fluoride, because fluoride is the highest electronegative atom in that row, so that's why it is showing the highest de-shielding effect. I hope these concepts are very clear to you guys. If you have any doubt regarding the any question, then please comment me, please ask to me, please feel free to ask the doubts, no problem, right? So in the next question, in NMR spectroscopy the chemical shift value is 10 ppm, means compound having dash dash effect. So 10 ppm means it is like talking about the delta value in the chemical shift, right? So if 10 ppm means the protons are de-shielded, right? Just now we have seen, if you are having the protons are having 10 ppm, or like in higher values of the chemical shift, so these protons are the de-shielded, और उसको हम बोलते हैं downfield effect, right? So what is our answer? So that is de-shielding or the downfield effect. What is the shielding or upfield effect? That is nothing but the initial stage of the chemical shift, like the delta value, that is 1 ppm, 2 ppm, 3 ppm. These protons are the shielded one, right? And whatever the that 10 ppm, like 8 ppm, 12 ppm, these are the de-shielded ones. And what are the values for the that 10 and 12 ppm? What are the functional groups? Just we have seen, that is the aldehydes and acids. Okay. Okay, that is very important. That is the scale, that is the chemical shift, like delta scale and tau scale. So delta scale is like 0 to 12 ppm. Here I have shown only the 10, but the delta scale is from 0 to 12 ppm, right? And tau scale is like 0 to 10, and these are the opposite to each other. Just like you are showing, it is starting from the 0 and end up with the like 10 or 12 ppm, but opposite, that is the tau scale, right? It's 0 to 10. So this effect also very important. Higher chemical shift, this side means that is the less shielded, right? This one, so just think about this one. These are the high chemical shift, less shielded, higher frequency, that is the downfield effect, or the low tau value. So that all the things about the higher ppm, right? If you are going towards the higher ppm, so you will get this point: high chemical shift, less shielded, high frequency, downfield effect and low tau value. So similarly you can see this side, it is the low chemical shift, उसको हम क्या बोलते हैं? These are the more shielded or the shielding effect. लोअर फ्रीक्वेंसी, दैट इज द अपफील्ड इफेक्ट, इसको हम अगर डाउनफील्ड बोलते हैं तो इसको हम क्या बोलते हैं? अपफील्ड इफेक्ट. और दीज आर शोइंग द हाई tau value, right? So these are the questions from the NMR. So thank you so much. In the next video we will see the another topic with the same explanation. So thank you guys. Please share the video, please like and please subscribe the channel. Thank you so much.